Hello, 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 and welcome back to another edition of the APAC Hybrid Cloud Kopi Hour. I'm super excited to be back here and having the show. As always, I like to give my reminder of what we're talking about when we say Kopi for those who are not in the region. Kopi is this wonderful coffee beverage you get in Singapore that our current guest probably knows a lot about. So I have my Kopi mug here full of Nescafe, but it is what it is. I am August Simonelli. I'm a technical marketing manager here at Red Hat. And as always, I am joined by Dev Schonbag, Principal Architect. Dev, say hello today.
Hi, everyone. Thanks, August, for the warm welcome. Another exciting show of Kopi Hour today. Unfortunately, my coffee quota for today is done, so I'm staying with water. However, very excited to be here and listen to all that our guest has to say today. A true trailblazer in the technology landscape. So I've really, ready and getting started to see what Vincent has to offer. Over to you, Vincent.
Yes, absolutely. So,
Wow.
yes, let me introduce you. This is Vincent Caldeira. He's Chief Technology Officer here in APAC. I am super, as Dev said, super excited to have Vincent here. He's the smartest guy I know. It's wonderful to have him here. Vincent, why don't you say hi and introduce yourself?
Yeah, sure. So, great to be here. This is my first time on the show. So, Vincent, I'm the Chief Technology Officer for Red Hat in Asia Pacific. I'm based in Singapore, so extremely familiar with Kopi. We don't use Nescafe though; it's a lot stronger than that.
Yes.
So generally, it's probably the best brew for us programmers who are having late night, session trying to deal with fixing bugs or getting software out. And yeah, very happy to be here and discussing the exciting topic of artificial intelligence and in particular the recent trend in generative AI.
Yes, absolutely. Well, and before we dive into the topic, one thing I have to note, this came across my LinkedIn feed. So you were named one of the top 10 chief technology officers in APAC by Technology Magazine. And I think it's really neat. I mean, it really shows your own abilities and skills and to be part of things. But I'm really proud as a Red Hatter to have you on that list. It's really a wonderful thing. It's really cool.
Yeah, thank you. I think, to me is, I think what's important is I'm very passionate about technology and evangelizing open source solution in particular. So I think to me, the greatest recognition is that probably some people out there in the region, they actually like to hear my message and, as a result, we have this opportunity to meet more people and share what we do at Red Hat, which of course is.
Yeah, no, that's well said. And I think the important thing is, Vincent shows up in Red Hat events and in open source events. He's part of some climate change initiatives, some really, really cool stuff that I think you could probably fill multiple shows about, but we're not. Today, actually, we're going to talk about AI, the thing on everyone's lips these days, artificial intelligence. And how I wanted to kick this off is Dev and I were talking before the show, and we're like, what do we know about AI? And sorry to out you here, Dev, but we don't know a lot, right? Our company, Red Hat, obviously is deeply involved, and we're going to learn more about that. But I wanted to look at like what I actually kind of my experiences with AI is. So I thought I'll do what everyone does, right? I went to Chat GPT and I said, oh, I'm going to get it to do my job for me. Write me a fun but short introduction to a podcast or live stream about AI. And so ChatGPT wrote this for me, and there you go. Unravel the mysteries, crack the jokes, and decode the geeky magic of artificial intelligence. And I thought, that's interesting. How does it do that? So then I looked at another one. I went to Bard, and I said, I'm going to ask it the same question. And this is how Bard responded to me. Welcome to the AI podcast. I'm your host, Bard, a language model from AI, Google AI. And then it made a joke. It made a joke that I actually didn't really get. So I don't know if it was trying to make the point that I had no clue, but it was interesting to see how I asked a robot the same thing and got different responses. And then finally, I thought, well, where else do people find AI? And they find it in image generation. So I went onto Leonardo.ai and I asked it to design me someone standing in the rain, looking mysterious, wearing a red hat, and this is what I got. which of course sent me down a rabbit hole that I just wanted to show off before I actually hear the background of it. I stuck Elon Musk in a red hat. I stuck Ruth Bader Ginsburg in a red hat. That wasn't enough, so I decided to stick a kangaroo in a red hat. That then became boring, and I started to play with some more interesting things where I was asking it to do like the New York skyline in a specific style, or finally to even just generate me a Kopi Hour podcast thing. So what's the point of all that? It's not just to show off my amazing artistic talent, but to say, what is AI and how is it doing that, Vincent? How is it taking this type of stuff and coming up with pictures of random people or a joke about synapses that I don't get? How does this happen? And that's where I wanted to leave it with you to educate.
Yeah, absolutely. So, I mean, spot on. That's really what I wanted to focus on today. I'm by no means a data scientist, so I'm really a technologist who's tried to really understand how AI things kind of come about in our life. And I think we'll be spending a bit of time today to really go through, I would say, an initial understanding of how generative AI comes about, right? And we'll go through some simple demo as well. So maybe let's get started.
Excellent. Yes.
All right. So I'll be focusing today really on generative AI in particular and the concept of foundation model. That's probably a term that you've heard. But when I ask people what's actually a foundation model, do you understand? Generally, people are not so clear in terms of their understanding. So we'll start with a little bit of a primer on AI and foundation model, and then I'll stop a while with slides to just go into a little demo to explain some of the concept. So where I wanted to start is when you look at generative AI, you can't really understand this without the broader context and the whole AI journey behind it. Yeah. So let's try to define a few terms before we proceed. So AI is really the generic term, which is the capability for computer system to replicate or mimic human cognitive function. Machine learning is really a subset of AI, which focuses on, it's basically an application of AI in particular. So if you look at machine learning today, whether or not you realize it's pretty much all around us and very pervasive already. It's used in prediction engine. A lot of prediction system, they basically look at, using existing data, compute the probability of some event happening, like a system failure, and then they pretty much generate predictions based on probability. A recommendation engine, which we basically use in our daily lives indirectly. You watch Netflix, you like a show, it's going to recommend more show for you. You go and purchase some good on Amazon, it's going to use other people's purchasing patterns and data to suggest as well some purchase that you may like. Is used in financials. So when you go abroad and you use your credit card to make a purchase, and basically the system is not expecting you to be spending money in that particular country, it may be stopped automatically and you may get a message from your bank. And it's even used in very much as a business tool. I mean, personally, I spent about 20 years of my life in banking. We are now heavily using machine learning for what we call algorithmic trading, which is really automating the behavior of purchasing or selling, either stocks or anything on the market, essentially. So
can I ask a quick question?
Yeah.
So
Yes,
when we talk, when we talk about it in a social media context, everyone always talks about the algorithm, right? Oh, the algorithm is giving me this or giving me that. Is that the same thing?
Yeah, so I mean, essentially, machine learning uses an algorithm, and of course, the algorithm itself depends on the types of machine learning models that you use. So it's a bit complex, right? But I would say at what's very important is to understand at least the big categories of learning. For example, you have supervised learning, where typically what we do is we have data that we label, and so we provide this data as an input, and we have an output that is known, and we basically try to find the best algorithm to generate the output. So typically how it's done is, you build an algorithm based on some data, and then you have some other data that you use for evaluation, yes. And so you basically run this algorithm to increase the predictive ability of the output, which is basically what we call supervised learning. Now, if you compare this with unsupervised learning, it's again another form of machine learning, but in this case, the model is trained on unlabeled data, and you basically let the model to discover the pattern on its own, and to predict some kind of output. So in that case, you actually use pretty different technique, and it's obviously used for different types of needs, right? So example of supervised learning, pretty simple one. You do sentiment analysis, right? You have maybe some announcement on the radio or a text, just telling you whether it's a positive or a negative sentiment. That's where supervised learning could come in. In our daily lives, we use spam filtering for emails. How does the system detect what is spam? It's using supervised learning to do this, right? Feeding a lot of emails and then literally like having enough data to show what's a spam. On the other hand, unsupervised learning is basically a little bit more loose. An example of this is, for example, marketing campaign. Yeah, you look at patterns of behavior of purchase of your consumer, and then you actually ask the system, could you segment those customers into different buying patterns for me? Because then the outcome will actually be different depending on the patterns you identify. So that's pretty much in a gist what machine learning can do and the high level categories of training.
Just another question to you, Vincent. So, as you just explained, unsupervised and supervised. So, unsupervised is more a powerful way of doing things, and supervised is more similar to you inputting something and then getting some back. Is it similar to the weak AI and strong AI, where weak AI is probably everyone knows, you put something in a chat GPT and it throws things out, whereas strong AI is something, for example, autonomous cars. Am I going in the right direction?
Well, I think it's a little bit more complex than this. I think weak and strong AI refer more to, I would say, the ability to kind of predict the result and to prove it. It's not it's not going to have exactly the same definition depending on the type of model you look at. Yeah, I think to me the way I kind of look at it is those are just different approach of teaching a system and learning. They just apply to different type of problem. So unsupervised learning in particular is really when you are kind of trying to make sense of data and to come with categories. And so there will never be an actual right or wrong algorithm, right? It really depends on your tolerance and how you want these classifications to happen, and that pretty much depends on the use case. While supervised learning, you can always kind of benchmark pretty easy the model performance because you know the expected output. In the case of unsupervised learning, you actually don't put. So that's the difference for me. Right? So the quality of the result depends on actually your usage, right? It's not so easy to kind of predict like what is kind of a good outcome or not. Yeah.
Gotcha.
So that's machine learning. And well, it gets a bit more complex now, but thankfully all these concepts are related. Is within machine learning, now we have the concept of deep learning. So what deep learning does is it's trying to really replicate, I would say, the architecture of a human brain. So we talk about neural network. And the idea here is we can actually connect a lot of layers of different neurons that can recognize and analyze pattern. So instead of having like a straight throughput, right? Like, oh yeah, you give inputs, you get output. Here we have potentially a high number of steps that are all helping us to solve much more complex problems that are not linear in nature. So deep learning can basically do this. Now the benefit of deep learning is because of this, I would say, architecture that mimics the human brain, we can improve accuracy and performance by quite a lot. We reduce the need of what we call feature engineering, which is in traditional machine learning models a very heavy task. So feature engineering is basically the technique to refine the data and the data quality. to produce new feature as input. So you basically improve the accuracy of model. In the case of deep learning, a lot of this work can pretty much be delegated to the model. And of course, it improves the scalability and the flexibility for solving problems. So when we look at deep learning, this is really the base that has enabled, if I may say, generative AI. Without deep learning, there's no generative AI. So now we take deep learning and what is really generative AI in the context. Again, we are talking about a subset because generative AI is solely focused on building system that can generate new data. It can be text, it can be image, it can be video, it can be audio as well. And these systems, they are not explicitly taught any language or grammar rules, or if you talk about image, like image style or definition, what we do is we give them massive amount of data, whether it's text or image. We get them to figure out the patterns by themselves. So basically, those are unsupervised model we are talking about, and they are also self-training model, essentially. We just pretty much give them the data. So what's interesting with generative AI is we'll see in the next slide, it uses a kind of set of technique and capability. It's actually, in effect, a blend of supervised learning and unsupervised learning. Because, for example, if we take the example of large language model, they will use supervised learning to predict the next word in a sentence, given the words that they know. But they will use unsupervised learning to figure out the structure of the language without instruction. So it's really kind of a blended way to actually approach the problem resolution.
And is doing that blend, getting to generative AI, is that new? Because like AI is not new. I mean, this has been around for a while. Is this a next step? Is that why we've suddenly it's everywhere? Or maybe you'll answer that, but yeah.
Yeah, I mean, exactly. So that like spot on. That was also, one of my questions initially when I started to look at this domain is how recent is this, right? Was generative AI really born with ChatGPT? So let me go, for a little bit of history there, right? How we got there. So first foundation models were only defined in 2021. In fact, by researchers at the Stanford Institute of Human-Centered Artificial Intelligence. So they published an analysis paper to look at what's out there, and they pretty much coined the term. And so there's a lot of definition out there, right? But I feel this one is kind of generic enough that it's good with me, and it's probably the one that I would prefer to use because it's broad. And it's really driven supervised learning, and it can be adapted to accomplish a broad range of tasks, right? So one element of the foundation model is they are not specific in nature. I gave a lot of example of machine learning earlier. And as you've seen, a lot of traditional machine learning is really much towards a very, very specific output. And if you need to solve a different problem, you very much need to come up with another model. Foundation model by nature, they are meant to provide capability that are reusable, that are pluggable, that can be extended to solve a range of problems, right? So to me, that's really the key aspect to remember. But let's look a bit at the history, right? So I have a little picture on the right to show the evolution. So I think the really foundational element from a technical and research angle to generative AI is actually in 2017 when the Google scientists published a paper that really coined and described what we call the transformer architecture. I mean, if you want to look it up, the paper is called Attention is All You Need. And basically what the Google researchers were trying to do is to build a neural network that understands the context and the meaning of relationship, right? So for example, if you have an English sentence, if you as a human, you read the sentence, you will know that certain words relate to each other. How can we actually teach a model to understand this relationship, to track those relationships in sequential data through just reading a lot of similar data. So transformer model, they basically use mathematics and probably not good enough to understand, the actual implementation of this, right? But they use mathematical techniques that are called self-attention. So these techniques basically they help to detect relations between data elements and how they are related to each other.
So you're looking for a pattern, right? It's looking for if someone ends a sentence with A over and over and over, then it's going to do it.
Exactly, right. So through seeing many sentences, you start to realize that, hey, this verb is related to this subject, and in the word "it" in this context, this is what it means, right? It's essentially it's building a relation in sentence,
Yeah.
right? So pretty interesting concept. So based on this kind of concept, it basically inspired the creation of large language model. The first one being BERT in 2018, which I think is probably a foundational moment of natural language processing. And so again, it was released by Google as an open source software, and it really much started the whole large language model. I would say a field of research and everything that we've seen until today with ChatGPT.
Okay.
Yeah. Obviously, Google did it for a very, very simple a reason that should be obvious to all of us. He wanted to make sure that in the Google search engine, you can actually type a sentence, and not just type a keyword, and Google search engine will actually understand it. Makes a lot of sense, right? And I kind of look back myself and I'm like, hey, actually there was really this point when suddenly Google search engine was able to return some meaningful data when I put a whole sentence, as opposed to somehow select some of the words and return crap. So I kind of found out that, hey, this is why. So that's pretty cool. And so in this flow of research, I guess the main public was kind of unaware of all this until around 2020, when researchers at OpenAI announced a very landmark transformer model, which is called GPT, at that time GPT-3. So of course, because it was made highly available to everyone to test, then it started to capture the attention. Mostly, I would say what GPT-3 brought is that this was the first large language model trained on such a huge amount of data at that time, 175 billion parameters. That had not been done before. So I think to me is the architecture was actually not new, but the scale was, and scale really made a big difference.
And how were they able to get that much data? I mean, deep pockets, or I mean, why was that the one that bridged that gap?
Well, so it's definitely not cheap. So you kind of need deep pockets, yes, to do the training. I think there's been a lot of kind of FinOps discussion recently about the total cost of training your own foundation model. It's not cheap, but also that's why foundation models are so exciting, because I would say in most business cases, you don't need to retrain them. You just need to fine tune them or give them additional data. But so essentially, so that GPT-3 essentially leveraged the architecture of the previous model, which is GPT-2. GPT-2 was what we call an autoregressive model based on the transformer architecture. But what was new compared to a BERT model is basically the pre-training approach that GPT-2 used. Instead of just pushing a lot of data and data set, basically in the training stage, the researchers started to provide contextual instruction. So they basically shared with the model and showed to the model what good likes, if you want, right? So that was kind of a new pre-training technique that was giving a lot better result. And they realized that with this technique, the more they actually scale with more data, and the closer to a human response the model gets. So they pretty much started to work just on scale. So distributed training just get huge access to a lot of architecture. I mean, we'll see later why this is interesting in the concept of Red Hat, is because this need to train at scale has made Kubernetes the de facto engine to do parallelized training for AI, right? which is where we're coming.
Yeah, and so Saad Sheikh asked a question on here. Can you share for the foundation model what size of data set you're referring to? So especially in context of on-prem customers and how much infra will be required. It's an interesting question, right? Because how do they do it? I mean, how is that done?
Yeah, I mean,
I don't know if you're going to touch on that later, but
I've never kind of trained my own model, end to end on prem. We're doing mostly fine tuning, right, from the development angle. I actually don't know how much space and training 175 billion parameter would take, right? But I've heard training costs in the range of $1 million US just to run,
right?
To basically train a foundation model of that type of scale. So that gives you an idea of how much infrastructure probably would be required, right? We're just talking about massive amount of GPU deployed at scale, and just basically forking this cost.
Yeah. Okay.
Just on the topic of costs, just wondering, you just mentioned, the amount of investment that goes into, doing this. Does that mean that in terms of accessibility, someone starting new has to have deep pockets, or, is there a as a service?
Yeah, so I mean, I think that's interesting, the type of model we see emerging. I think there will be models of as a service. I mean, of course, ChatGPT is the most famous one, but I mean, let's be honest here. I don't see a lot of enterprise actually leveraging it in the context of a managed service. Why? Because, essentially it's a model that's been built for, I would say, kind of consumer usage, right? It's not really specific to enterprise use case. And also, enterprise really have problems with sharing their data. Although essentially, of course, OpenAI is saying that they don't take the data you share in a prompt to train their own model. I mean, this being said, you are still pretty much sending the data to them through some kind of API call. So you have like no way to verify what's really done with it. And then you are literally exfiltrating information that may be sensitive, and in the process you may be violating data residency laws or data sensitivity policies that you have internally. So I think the way I look at it is, and that's what as well I want people to really kind of keep in their mind is, foundation model is this huge opportunity for people to leverage big investment in infrastructure and scale that the common individuals or organizations will not have. It's the point. You don't have to actually redo everything. It's opening fantastic opportunity as well for open source to build not just model, but also to contribute open source data that can be used to train this model in I would say in a transparent way. So let's be reminded of one of the key benefits of open source is not just that it's free software and so on, is that it gives you this whole transparency on the process, right? You can see the code, you can see what data has been used to train the model. And then if you need to basically improve it or fine tune it, you can pretty much take it and start from there. And so that's the way I look at it. From my perspective, a lot of the discussions I have with Red Hat customer, I feel that most use cases are actually use cases that people want to run internally with their own data. And therefore, they are rather on kind of private cloud type of model rather than on a public or managed service model. Yeah.
Thank you.
All right. So let's go maybe now through some implementation. So what I really want to get there is give a sense of, I would say, the steps and the key terms involved as well. And what you see here is really, I would say, a developer-centric point of view. Yeah, most developers today, what they do is basically what we call in-context learning, which is, basically means that they use a large language model off the shelf. And then they control the behavior through some capability, which we call the prompting, as well as how they actually ask the question, which means the contextual data that they actually pass. So there's kind of a few sequential steps in this process that are worth knowing. This is what I'll try to demo very quickly just after this. the first stage is really a data pre-processing a step. So in that step, we'll use what we call embeddings to store private data that is used by the model to understand better your query. So an embedding, you have to see it as a way to represent complex information like text in what we call a vector. And so this vector basically will be stored in a way that the system can actually quickly identify a relevant piece of text and information based on a query, but by using, obviously mathematics and some score that indicates the relevance. Yeah. So generally, the first step we look at is, let's see what data we want to give to that model, so it can provide us with a better answer. And the way of doing this is what we call those embeddings. Now, the second step is really what we call the prompt construction or retrieval. So when you submit a query, you can basically give some instructions for the model to return an answer. So you've probably heard about prompt engineering. Prompt engineering is really the art of designing a text that helps the model get a better, more compliant output with what you expect. Yeah, ideally it's concise, and it increases the value of the response by filtering the inappropriate ones.
Yeah, so I think it'll be the next start. Like in those AI images, the prompts that I was using, and some were huge, and then there were the negative prompts, like no extra fingers and all these other things, because it tries to do that.
Exactly. Yeah, correct. So it's very much still an art, but if you are interested, I was reading an article recently on the future of generative AI is not prompt engineering, which I found quite interesting, which basically was explaining that over time, as we prompt them, the model will also have the ability to supervise themselves because they can learn from our prompting. So yeah, it's
okay, I'm a little scared, but yeah.
When does it ever stop?
Yeah.
is the question. Yeah.
So you're saying there will be a dev's version of the prompt already ready, or a Vincent's version, an August's version?
Yeah, I mean, exactly right. You could be like models that are personas, and then they have some kind of capability of prompting. But some could be a more aggressive prompter. Some could be maybe more delicate. I don't know, right? It's kind of interesting, but it's really a topic where like most of the time it just blows my mind, like what is actually doable. But yeah, so I just wanted to share at least that kind of the high level concept. Yeah. So they are all familiar with it. So maybe let's move on to some demo, so we can actually see the this in context, right? So the demo will be really 3-step, and as usual, all available on GitHub. Those are just simple notebooks in Python that anyone can run. We'll go through model input and prompt engineering. I'll use the example of a pet name generator. Then I'll show you what an embed looks like. It's really sexy at all, just full disclosure. But it's kind of interesting to see how it looks like. And then we'll go through question answering through embeddings, right? So you just see embeddings in use. It can do more than just question answering, but that's typically the most obvious use case. So we'll basically go through that. Yeah. Okay. So let me stop sharing this, and then share again.
Yep.
My demo. Can we see everything?
There we go. It should. Yeah, it's getting clearer.
All right. So
can you make it a little bigger, or is that not going to work?
Okay, good point. Can I? No.
That's all right.
Wait. Yeah, okay.
Oh, yeah. Right. See how that goes.
I thought he was not reacting to my inputs, but it's a bit better.
It should have learned. It should have known it was being shared, and then predicted that it needed to get bigger. Anyway, move on.
Yeah, I mean, actually, come to think of it, given my eyesight now, it's not a bad font size. So, all right. So we're really going to start with inputs to a very known model that we all use for the swanky web interface, which is ChatGPT. I'm going to use the GPT-3.5 Turbo because it's faster, but also it's cheaper. So bear in mind that every API call goes to my credit card. at the back. But I mean, I'm just joking because it's quite cheap. So
Yeah.
really like no harm done here. We are actually using OpenShift Data Science at the back, but in particular, just Jupyter Notebook, because they are pretty good, to basically do experiment and to show these kind of steps. So essentially, I'm using the Python API for OpenAI, which has been pre-installed because it takes time. And then we kind of going through, hey, how do you actually interact with this model? So the way it works is you specify the actual model that you want to use, because OpenAI gives you access to a few of them. And then you have a message format where you basically pass the prompt of three different type of messenger. One is the system, which is the actual prompting, right? So it's kind of the context. One is the user, which is you, and assistant is very much a ChatGPT itself replying. What's interesting and what I found out is you can actually pass an entire conversation with the assistant answer as well. Yes, if you want to actually influence and give the context of an entire discussion to the system. And of course, the content is what you pass. So let's see a very simple example of content, right? So I have a whole discussion here. I'm asking really OpenAI to be a helpful assistant. And then I say knock, knock, asking who's there, and then I reply orange. So right now I'm just kind of firing this API call to OpenAI. So this is like the whole message it returns, right? It gives me the model context. Interestingly, for every computation, you actually have the token spent, which is basically an idea of how intensive the computation was on the OpenAI side. And then it basically returns to me the content, which is basically the next sentence. Now, if you just want to extract the content itself, you pretty much just need to pass the response, which the API allows. Yeah? So that's very simple. So now we talked earlier about prompting and then contextual learning. So here is an example of prompting and contextual learning. Yeah? So my prompting is, I want OpenAI to be a helpful assistant. And I want OpenAI to define asynchronous programming in the style of the parrot Blackbeard.
As you do.
As you do, because I mean that would actually kind of spice up the Red Hat documentation. If we were to actually use this for a bit of creative writing. So essentially, it's generated a response for me that's really, I mean, I haven't met Blackbeard personally, but that kind of looks like something that you see in the pirate movies. So that's all there is, right? And I mean, some of those things, as you can see, it will just influence the type of answer you get from the model. I mean, if I don't pass the prompt, I'm still getting a pretty much contextual answer with Parrot Blackbird, but maybe it's kind of influencing exactly how the model actually replies to me, and then what type of wording it actually uses in the
So
process.
if you said in the style of a leprechaun, it would say, okay, when leprechauns speak, when someone's designated something as a leprechaun, it had something. Or if you said in the style of a professor, it would see stuff in its model.
All right.
Yeah.
We can try this. Let's see. He's it. Oh my goodness. So we are just doing really simple API.
Wow, look at that.
This is really
now,
cool.
right? So that's interesting, right? Because now it's like a professor, but to me it's like that's like a school teacher. And maybe professor, you meant more of an academic style.
Right.
And so probably you will use the prompt engineering to basically derive more of an academic answer and not a kind of contextual answer that I'm in a classroom.
And it's wordy, right? Now, imagine a scenario like it's very almost paternal, right? That's incredible. That's cool.
Yeah.
It
So
is.
that's
It's
so
been
that's
there for a
really,
while,
yeah.
but every time this happens, it amazes me. Speaking of influence, Vincent, if you could influence the documentation team to write our documentation for for each person, like I'd love it in Jack Sparrow's message. I don't know who your favorite is.
Yeah. I think I strongly suggest, right, at least, for people who are not familiar, I think to me is I'm not really afraid about, hey, AI is replacing or whatnot, right? I think it's really about at times just efficiency. I do make a lot of use right now of OpenAI, which is why I have a subscription to at least help me with really structuring flow of information, because I really have to deal with a lot of documentation information, and a lot of my job is, hey, you've got 10 minutes to explain a concept or an idea to someone. It's just very good at kind of summarizing, giving you a kind of way or an angle that you could actually explain something with like less word or in a simpler manner. um, and yeah, it's just kind of helps. I mean, the way that we improve AI, I feel AI is also improving us and what we do, if we can use it responsibly and properly. Yeah.
Right. And I guess, and the risk here is that you don't know anything about, not you personally, but one doesn't know anything about what they're doing and using it for that purpose. Is there a way we can train AI on our own information? Could I have it scan all my Google Docs and then help me
Yeah.
write my own responses using me as the model?
Uh, Absolutely. So hang on. This is what we'll do in step 2 with the embeddings. So we'll have an example. So let me go through this to illustrate another fun example,
Yeah.
and then we look at, hey, how do we give data now? So here we are looking at a very simple use case, which is we kind of trying to build a fancy pet name generator. So what I'm trying to do here is, really starting simple, ask for a name for a horse. And then let's try again and see, well, now if I ask for a name for a black horse, would it actually influence what OpenAI responds, which is like, hey, absolutely. Yeah, Midnight seems like a very nice name for a black horse. Now I'm trying something a bit more complex, which is suggest 3 names for a horse that is a superhero. Yeah. So those names are a little bit more creative, which is nice, but that's not exactly what I want, right? I mean, like how a superhero name typically is generated, as you all know, like, Captain America or Lord Thunder or whatever. Yeah. So I'm going to use contextual learning now in the next, call to show how this is done. So if you can see here, I'm actually providing OpenAI with example of how this kind of name is actually generated. Yeah, so I've used cats and dogs as example. And so I basically now asking him to complete the sentence and suggest 3 names for the horse.
Oh, wow.
And here I am, with 3 pretty cool horse names. Yeah. Now, interestingly, if I keep running this, you'll see that it pretty much always generates very, very similar names. So there's no real creativity, isn't it? It's all probability. It's probability based. Yeah, it's finding the most likely words to actually give you an answer. Now, this is where it gets very interesting. There's actually settings to the model that can basically influence how creative it is. Like, so you are basically telling the model that, hey, you may not want to follow the best probability every time. How about you take a bit of freedom and basically be more creative? Yeah. And this setting is what we call the temperature. So if we look here at this message where I've got the temperature of 1, yeah, in the past I used temperature 0, which is basically telling the model you stick to the most likely answer from a probabilistic angle. With the temperature of 1, I'm basically the opposite. I'm basically in the creative writing space. Yeah, take some liberty. And so now I should actually start to see new names, yeah, coming up. Like Stallion Savior, I think was not there. Yeah.
Yeah.
So that synergy is what I wanted to show, but like it kind of gives you some idea of the art of the possible here in terms of just interacting with the model. Yeah.
Yeah. That's incredible. And so, yeah, you see how I could feed it information about me, or so now this makes sense to me, because one thing I did, and I swear I didn't do this for the kid, but I said, write me a speech like a 10-year-old, right? Because she had an assignment. I didn't let her see it, and it did it, right? And so I can see how I could set the temperature, how I could set, these prompts that I didn't even know I was doing to get it to use the information in a certain way. What I didn't try is write it like I'm a 50-year-old and write it like I'm a 100-year-old, because it would have come out different, and that would have been a wonderful test. But that was really cool.
All right, so we'll come to the next step now, which is, you may want to have some contextual data that you pass as well, because there are things that OpenAI hasn't really trained with. So in this example, and I'm not going to run everything because it generally takes a bit of time, so I've run the demo just before this as well to make sure everything processes. But essentially what I want to show is we download a few hundred Wikipedia articles about the 2022 Olympics, and then we basically chunk them and we create what we call those embeddings, which I mentioned earlier. We put them into a vector, and then we use this to basically pass to the model and help him answer questions about the 2022 Olympics. Now, you would ask me, why do we need to do that? Essentially, because we will see here later with question answering. If you have used in the past the ChatGPT open to public, which relies on the ChatGPT 3.5 model, it actually does not have any training data after 2021. So we would actually not know about the 2022 Olympics. Yeah. So that's why we may actually want to pass data. So in this example, I'm using a nice little API that gives me access to Wikipedia data, and basically I gather all the 2022 Winter Olympics articles, and basically we have a total of 732 articles referring to Winter Olympics. So from there, mostly what we have to do is really not a very pleasing task, if I may say. It's pretty boring, but we have to spend time cleaning up the data and basically splitting it into relevant paragraph and sections that are relevant by themselves and that stay relatively short so that they are usable. So we go through a series of steps to basically ignore certain sections of the articles, stuff like bibliography, sources, citation. They are not interesting to us. And then we basically associate them with their title, and we split them into sections. So out of 732 pages, I basically created 5,742 sections of text, which I then proceed to clean up by doing various filtering, removing blanks, and so on. A lot of really not interesting code. But here this is how it looks like, more or less, once we have done the cleanup, right? We've got basically some keywords, some short description for each section, and then we have like a bit of text that is basically a single paragraph. Yeah. So once we have a smaller section, we want now to create what we call the embeddings. So for this, again, we use a model that is provided by a GPT. And we are just going to basically pass all these chunks, again, to create all those different embeddings for us. So essentially, now I'm trying to show you a kind of readable section of it. We have something like this, name of the person, this is the biography, and this is kind of some information about this person, as an example. So we want to pass it into a chunk that will be usable in the future for search about this Michela Morioli. So what we do here is we have an embedding model, which is provided by OpenAI. So that's kind of the baseline model that is probably in most cases considered that the one you should be using if you don't know exactly what you are doing. Yeah, there are others, but probably you need to use them if you actually are really aware of why they are relevant. And then we basically start to run some queries, batching them by sending 100 elements at a time to this model. And what it really does for us is it takes this chunk of text and then it pretty much returns a vector. Yeah, so we built a total of about 6,000 plus vectors, and then we save them in a CSV file, not because it's a good idea. It's actually a terrible idea. You would normally not use a CSV file. You will use what I described earlier, which is a vector database. But the good thing with the CSV file is I can show you kind of what it looks like here. Yeah. So like you see here, now we have these rows of text. And then in front of the text, we have a vector, which is basically coordinates, multi-dimensional coordinates that the system will use to understand the likeness, between different parts of text. All right. All good with this step. Not the most interesting step of all, but it's kind of a preliminary. Yeah. So
Right.
back to your question earlier, like this is what you will have to do. Of course, it's not. I'm not showing you a state-of-the-art pipeline to generate embedding. I would say it's a 101 explanation, but like if you're trying to teach a student what it does and you are at the starting point, that kind of gives you an idea of the process. There's obviously a lot more in terms of automating the cleaning, like structuring the data for optimal performance that we are not kind of looking at or discussing here today. Yeah, because we are really in a 101 session sort of. Yeah.
But it explains what you talked about with learning like a brain, combining the models and how this is pointing to that is pointing to this and how it can be so in depth. Yeah.
Exactly, right. So to me, although it's really a long time ago, I used to be more of a scientific and math person, and that to me is interesting. The fact that you have this multidimensional vector really use and you basically use a cosine function to relate whether a vector is close to another. Is I kind of never realized that this is actually what the maths is helping us to do. Yeah. All right. So now we come to the interesting part is we've got those embeddings. So what are they used for? So let's start with first some, I mentioned it earlier. Why do we even need to do embedding? So the first thing is GPT and large language model, they typically can learn through two ways. One is through model weights and one is from model input. So model weight means you go back to the training data set of the model and you fine tune it. This is great for big structural learning. So, for example, you want to teach a language model to learn Python programming, you'll have to do this kind of fine-tuning and training. It's not going to learn Python just on its own. Most likely. You can try, but I don't think the result will be fantastic. Now, if you don't want to, you don't have to build any kind of structural capability. So in our case, we are just still using language and English language. It's actually much faster and less costly to just use what is a model input. So we use those embeddings as additional inputs, additional information. It's a bit like short-term memory, right? You are giving this short-term memory for this person to answer. I think everyone can understand this, right? If you ask me any question about 2022 Olympics, I won't be able to answer. If you give me access to 600 articles about the Olympics, well, you know what? I can read the articles and find the answer there. So that's pretty much what we are doing. So here, what we'll really go through the full kind of process, which here is pretty much, let's try to ask the model first. So I didn't give any additional context. And now GPT is telling me, well, I don't have the real-time data at all. 2022 Olympics is not something I know because I've been trained for data before. So it's just being very honest here, but it doesn't have the data, which is actually pretty good. But there's kind of no solution to it until you pass some information. Now, I have a very simple example, not just passing the one Wikipedia article about curling to sort out this question. So I'm just passing this article as a string, and I'm just showing to you that, hey, this article actually gives me who are the medalists for curling in the Winter Olympics in 2022. So the answer is there.
Yeah.
So just by passing this text, what we want to check is the model now able to answer this very simple question about who got the gold medal? And ta-da, there it is. Yeah, it's been able now to parse the content and tell me the correct answer. And so that's pretty much what we are doing. But now, of course, we don't want to pass every single article one by one. I mean, and especially given the fact that if we do have the article, we actually don't need the answer from ChatGPT because we have it in the article itself. So we are going to use the embeddings now to really look at all this. So here I've basically used this entire pre-trained CSV5 that I showed earlier. And so just to show to you that we have 6,058 rows with this vector. And then we build a search function that will basically rank the different string into this data structure by relatedness. For this, we are using some maths again, which is a cosine function, which helped me to really get a score on how related the articles are. So what's cool now is if I pass a term like curling gold medal, it's going to start finding, like going through those embedding and finding relevant ones, and also giving me a score of relatedness to my ask. Yeah. So that's how it does essentially. It's telling me, hey, this stuff looks pretty good, 0.879. This one is slightly less good, and so on. All right. So now we can build an ask function, which will use this capability to provide answer on the 2022 Winter Olympics. And just to make sure that the model is using, this data, we'll basically use prompt engineering here. All right. So the ask function is a dumb function that can pretty much only answer question on the 2022 Olympics based on the data we are passing. Yeah, that's all it can do right now. Let's just verify that it can do the job. And that's it. Yeah. So it basically gave me some answer. You'll see though the answer is not perfect. Actually, the answer right now is given me the men's, the women's, but there is not the mixed curling tournament somehow. We're not going to go into the detail on this because I see we are already short of time. But so is there's obviously in the APIs way that we can troubleshoot the answer of the model. So when I actually pass a true flag to this function, it's actually helping me to understand how the model selected, which content first the model considered, and then which answer it actually selected and why. Yeah, so if you are really into this kind of thing, you can read this multi-page output and really figure out by yourself how you can actually interact better with the model.
Yeah.
Does this make sense?
That is awesome.
Yeah, it's giving me a sense of what's happening behind the scenes and how complex it is, which, I mean, I knew, but you call this 101. I mean, wow. This is, yeah.
I mean, to me is, I think what's important is really to understand the flow and the concepts. The beauty is, again, what I like in this field is, to me, I consider myself more as a data engineer than a data scientist, right? I've already been in the data field for years. This is not new to my Red Hat stint. But like this type of capability has really transformed the way I can do data engineering at scale. There are tasks out there that I used to spend, literally weeks to really kind of improve data quality, automatically classify, and so on. That stuff has literally changed how I can actually, do my work. So I just think that for anybody just to be able to understand this is to understand, hey, this is where it could help me or fit what I do is actually pretty exciting. Yeah.
Well, and if you have a bit more time, I'm happy to, we can keep running a bit. So.
Absolutely. I mean, we're going to try to, at least, I like to spend hopefully 10, 15 minutes, at least to go through the AI strategy. So let's just finish quickly with generative AI in the real world, right? So we've seen a lot of language related. They are probably the most, I would say, mature right now, because we've seen the transformer model, was initially applied to text. But, we've seen through your examples, August, it's applied as well for visual. I mean, I myself as well, I'm a avid user of Leonardo.ai to generate images. And then it can generate audio as well. Yeah. So one aspect that I would like to highlight, though, because to me is also pretty fundamental, is generative AI is a big contributor to improving AI as a whole. Why? One of the key problems we have with AI is having good quality data. Guess what? Generative AI is also used to generate synthetic data. So you can generate synthetic data with high accuracy because it's now using model and deep learning to do that. And then you can use the synthetic data to train better those generic models, those machine learning algorithms that we discussed earlier, right? Those fraud detection and so on. Yeah. So that's pretty cool. So, you look at cases like automotive as an example. In order to rapidly train those models for self-driving car, generative AI is able to build, those fake 3D world that can be used by the car to just automatically train out of synthetic data. So it doesn't have to go out there and kill a few passerby to learn that this is bad behavior, because generative AI is telling him that this is actually what could happen.
Yeah.
I mean, like, again, how cool is that, right? So lot of benefits we've seen. Is able to generate all this algorithm content by itself. It's able to help you explore data much faster. It's able to accelerate tasks and processes. Now, before we move on to Red Hat strategy, just a few key aspects on the challenges. Yeah. The key challenge is the scale of the compute infrastructure. When you have these billions of parameters, training at scale requires heavily distributed system. So it's not just the cost, it's just the actual task of coordinating a model training is actually very complex. So that's the number one problem. Large data set means massive compute. Interestingly, a lot of people who are good data scientists, they are not necessarily good infrastructure people. And people who are good at infrastructure, they don't necessarily understand data science. So that's why this field is seeing a huge demand in people. The second challenge is what we call sampling speed. So this one is really about the fact that, because this model have so much data, and high quality data is needed to have accurate answer, they have reasonably slow speed to basically provide you with an answer. So from the human perspective, you see an impact. Now, obviously, in certain use cases, all right, because you can just wait. In some other use cases, it may be detrimental. If, sometimes you may want a fast answer that's good enough rather than a long answer that is very accurate. So there may be some limitations there, which is why you see a lot of models that are trained with different amount of parameters, which basically give you the choice in terms of amount of compute and speed that you get in terms of getting an answer. So you will see a lot of models, they have some name, like you'll see 7B or 170B. B stands for billion, and billion is pretty much the number of parameters that are being passed. So that should kind of give you an idea of what it is and why it makes sense. Other issue is, of course, data quality. To generate data, well, it needs data. So I mentioned it earlier, the 3D model. The biggest issue is actually data. There are not a lot of 3D models of the world today available. So you need more to train the generative AI so it can actually do this. It cannot just miraculously create model to kind of train off. So let's be aware of it. And the last one is, you've probably seen some articles recently, is, I would say, not just data, but model licenses. When people say this model are open source, not exactly in the true sense of the term. I think a lot of people are kind of now rising to, hey, why are they calling themselves open source? And most of these models are not open source from the true sense of the term. as it is defined by the institution, right? But my view is this is expected because I think it will take a few years for AI, which is a new field, to find kind of the right way and terms and licensing model to basically operate, right? We can't be so impatient. I mean, again, this thing did not exist much like just a few years back. So I would tell all the open source fanatics, I mean, I'm one myself. We've got to work with the open source community to help people understand the fundamentals of open source, what we're trying to achieve, and hopefully we will see new permissive licenses models being born, so that we can actually spread the capabilities. Yeah.
And we'd be confident of that. I mean, open source it's not new, and so that's very clear. And I think that puts us in a great spot. But yeah, patience is an important message there. That it's taking a lot of money and a lot of folks to do this. So let's get there. And how could Red Hat help? That kind of stuff.
Exactly. So perfect introduction to the final section, which is what is Red Hat doing about this, right? So Red Hat, the way I look at it is, again, I tend to have the point of view of the developer. At the end of the day, what I like to do is develop software. Generative AI or AI in general is an additional tool that I now get into my toolbox. So the way I look at it is that if you look at the software system engineering cycle, we talk a lot about DevOps, CI/CD, and so on. Now we've got this additional loop, which is the AI modeling cycle. And so if you build an application today, chance is you want it to be an intelligent application, not just a dumb application with a lot of if, then, else, and hard-coded choices, and you want to use AI. So you have to see this AI capability as something that needs to integrate with the software. Now, why this is interesting from a Red Hat point of view is because, of course, part and parcel of what we do is helping people to build their DevOps capability, work with infrastructure platform to really make sure that the data scientist, the data engineer, the developer, the ops team, they all work together to happily integrate all those capabilities in a way that is really agile. Yeah, so that's the way we look at it. So we really focus on, I would say, the life cycle and making the life cycle less painful as much as possible, which is how do we help people to develop a model? How do we help people to serve and monitor the model once it's ready? How we automate the whole life cycle management, and how we help the collaboration with the developers. Yeah. Now, so this is an important part of our messaging, because it really defines, I would say, what is the DNA, in my view, of the Red Hat solution. Is why would you like to work with Red Hat in this space? There's a lot happening. There's a lot of great AI company out there. So why Red Hat? So for me, I see really four main aspects of what we do and why customer would actually want to partner with us. The first one is we are really focused on collaboration. So the way we look at it is we don't want to provide you a platform that is great for the data scientist, but then the developer is totally isolated. And so we are really looking at building a unified platform for the developer and the data scientist to build intelligent application. The second aspect is we have a platform that, we mentioned some examples earlier. If you want to train the system with your own data, and this data is too sensitive to go on a public cloud, you may want to do the training on-prem or on a private cloud, and then deploy the model on a public cloud. That's a use case that is extremely frequent in a lot of the industry I work with personally. Public sector, healthcare, financial sector as well. The kind of hybrid model, the ability to train a model consistently on-prem and then deploy it on the cloud and it just works is very important at this stage. The next reason is ease of access. Generally, our focus for us is not to build the actual model. Red Hat's focus is not the actual AI expertise. It's really to make access to this complex resource like GPU very, very easy, right? So a lot of my customers, when I ask them today, how long does it take for a data scientist to get a new cluster to start a project? we are talking about weeks, sometimes months. The way we look at it is we want to build self-service capability. You go in some kind of a web interface, define how much space, how much power you need, press a button, no IT guy behind the scene, kind of deploying a cluster, like making sure you have the proper size, the right type of GPU, and so on. And all about automation. And then last but not least, of course, our approach is totally based on open source. Yeah, so you've seen in this discussion so far, open source, I think in AI, just like it has been in the health sciences, actually, has been really the innovation mechanism for AI ML in general. Almost everything out there today, from the papers released by Google to the first few models, to what we see now happening with provider like Hugging Face, providing all this capability in their open source offering. All this innovation is driven by open source. So what we know is it's going to keep changing as you actually adopt the technology, right? Let's say you spend 1 year of your time implementing this fancy new AI platform, which has this model ABC, and then you find out that 1 year later, those models are probably obsolete, or there's like better version of it. The only way to stay relevant is to be able to quickly take a piece of open source technology and then deploy it. And so that's pretty much what we focus on. So in essential, and I'm not going to deep dive here, but I like to describe that we are really a provider of ML ops solution. We're trying to piece the entire process to build models, deploy them, and integrate them to be repeatable and automated. Yeah. And so this is how complex a pipeline can be. So just to give you an idea of, hey, actually it's kind of nice to start with some kind of a model and just kind of tweak it to your needs.
Yeah, and I think it's important what you're saying, just real quickly, is we're not selling a product to do this. We're selling a process. We're selling OpenShift is a product, Open Data Science is a product, but there's so much more than that. And I think you're illustrating that nicely. Keep going.
Exactly. Yeah. So that's like a great point, because to me, I think some people try to compare this with some machine learning product, for example, which have like auto ML capability, right? Those are those products that, hey, you pass them some data, they help you to tell you, hey, maybe this model would work well. I mean, we are not this kind of product. Typically, we work with this kind of provider. We are more addressing the more fundamental stage, which is the infrastructure, the automation behind it. Now, let me go to the transition, right? Because what we've done so far, which is OpenShift Data Science, which is part of OpenShift AI as a value offering, is really very much the wires, right? Now, we are going in the foundation model era. And so what's next for OpenShift AI and its offering? Well, the part of the problem that we're trying to focus on is really what we've been going through in this show today. Foundation model require this huge amount of infrastructure and data to actually be useful. So from a point of view as a platform provider, a lot of the contribution and work we've been doing internally with our engineer is really how do we make it easier for these people who are data scientists to have access to this complex infrastructure and resources. How do they queue workload? How do we manage the scaling automatically for them? And how do they pretty much run the training? And how do we also avoid a situation where those people who are the engineer, the cluster administrator, they are not constantly kind of having to do this for the data scientists, like more or less manually. Yeah. So that's really what we're trying to do. And so I really finish with this, but so that's the exciting part for me, because we are entering into this next stage now of our OpenShift AI roadmap. We've actually published a foundation model architecture jointly with IBM. So it's been built with IBM Research in collaboration with Red Hat. And this architecture has an open source stack called Codeflare. You can find the repository of that on GitHub, again, obviously open source. And this Codeflare stack solves a number of challenges faced by the data scientist and the administrator. Let's look quickly at the stack, right, that you see on the left. So it provides you an SDK. And this SDK is basically a way, like, to you as a data scientist in your Python code, you can basically start running job, you can specify them, you can contribute infrastructure remotely to distribute computing jobs. So you don't even need to understand how many servers, how distributed they are, where they are located. You don't need to understand anything around Kubernetes and how Kubernetes scale. We give you a simple SDK, which is a programmatic way to access this infrastructure for heavy parallel compute. And through this SDK, you use these two components, which is the multi-cluster application dispatcher, which handles the queuing, the resource quota, the management of batch job, and this component called InstaScale, which is doing the on-demand resource scaling on the OpenShift platform. And so that's really what it's about. So thanks to this, we basically are able to provide easy access to data scientists to infrastructure from something that they are familiar with, which is a Pythonic interface. Important to mention, they don't need to rewrite any other model training code. So if you are using a framework like PyTorch, TensorFlow, you pretty much think PyTorch code and you just distribute the training. For this, we are using a technology which is called Red.io, which is a very, very cool open source project. Look it up if you don't know about it. It could be a session on its own, but that's basically what we've been leveraging and contributing to the back. Now that means as well for the IT administrator, you guys out there who like me don't like to have to look up tickets and provision infrastructure manually. We've got a solution to pretty much have a stack deployment model that runs consistently on any infrastructure, cloud, on-prem, and that pretty much abstract the management of resources for you. So you can focus on FinOps, optimization around AIOps, and so on. And so that's what I wanted to share today.
Wow.
We've overrun by about 15 minutes, but hope it was actually useful for you guys out there.
That was terrific. And that OpenShift AI umbrella, I think, is important because, we announced OpenShift AI at Summit, and it's not, I can't give you a box that contains it yet. And I think you're giving us this peek under the covers of what's coming. Not that it's secretive, but just that it's new and it's out there and it's a new field, and it's neat to see those pieces underneath.
Yeah, I mean, I think that's the thing that is always, important. I think, in our interactions with people, right? I spend a lot of time with customers. For some of them, it's good to understand that we have this capability now, and probably it's going to be stable more like next year. But then for an early adopter, you can pretty much work right now with Red Hat to kind of try it out, to teach the technology to your internal people. So you kind of get to choose based on your appetite, and like aspect I like is if you want to be an early adopter, you have this fantastic opportunity to channel some of your inputs via people like myself. And the most exciting part of my job is to take all the inputs from people who use the technology and then go back to our engineer and share how we can improve the product. Yeah.
Yeah, I know. And having worked at Red Hat and working at Red Hat, I see Vincent doing that daily. He's out there literally taking that input and having conversations with engineering, consulting, marketing, everyone. It's really, really, really cool. It's a great model. So yeah. Well, I'm amazed. Deb, I don't know if you had any final questions there.
No, I was just mesmerized by all the things that we learned today. Amazing demo that you shared with us, took us through the inner workings. Really glad. And just like we gravitated towards all that, the passion really comes out, Vincent. I'll be honest here. I'm sure people would like to connect to you, and they've got your details. But thanks for doing this. Really appreciate it.
Absolutely, it was my
sure.
pleasure.
So
I think,
yeah, Vincent,
opens a lot of future sessions potentially.
Yeah, well, so I'd like to add your slides to the show notes and stuff like that, if that's okay. Also, I want to remind folks that Red Hat Summit Connect is coming up. I think you're probably at some of those sessions, Vincent.
Yeah, I mean,
they're
so
across
some of them. We are in a lot of locations, so we have to divide the traveling. But yes, I'll be attending some of those sessions in person. Singapore, definitely. I think India as well. I'll probably be there in person.
Excellent.
Still kind of figuring out.
So head out there. You can see Vincent at those events live. There'll be coverage of a lot of AI stuff and a lot more. What a great show. Again, we'll be back again in a couple of weeks with actually, I think our next show is on automation, which is super exciting. And we'll touch again on AI because it is really everywhere right now. And it's important to the strategy and to the way things are going in technology. So that is super exciting to have that option as well. Outside of that, I think that's all we have for today. I am so thankful for the time that you were able to spend with us, Vincent. If you have any final words, I'm welcome to hear those. If you have anything you want to add.
No, I mean, that's it. Obviously there's a lot of like potential focus follow-up. I mean, like do share my contact with people as well. They can approach me safely for any cool discussion. Always open for it.
Yeah. I'll update the notes with that and a link to the slide deck, and people can reach out, and that'll be terrific. All right, everybody, let's wrap this up. It's been a wonderful session. I thank you very, very much, and we'll see you next time for the Kopi Hour.
Yes.
Cheers, all.
Bye-bye.